everyone. My name is William Morgan, and I am one of the members of the Linkerd project, and I am joined today by Lynn Sun. Lynn, do you want to introduce yourself?
Yeah, hi everyone. I'm Lynn Sun. I'm a senior technical staff member with IBM. I'm also a contributor on the Istio project.
Great. So this is going to be a historical talk because we're going to be splitting this talk down the middle, and we're going to talk about problems that are kind of independent of Linkerd or Istio, but apply to the service mesh as a whole. So the title of the talk is "The Service Mesh is Still Hard: All the Things We Did Wrong and Tales of Woe." So hopefully that entices you. Here I am. Here Lynn is. And I'm going to split this talk. I'm going to kind of take the first half, and then I'll hand it over to Lynn for the second half. Okay, so the agenda is we're going to talk about kind of the general concept of the trade-off that's involved in taking a service mesh and introducing it into your stack. I'm going to talk about some terrible things we did with Linkerd. Lynn is going to talk about some maybe terrible things that happened in Istio land. We're going to try and describe lessons learned from those, and then Lynn will send things off with a rousing conclusion. So hopefully we can make this interesting and entertaining for you. So here we go. The service mesh at its core is an abstraction. Hopefully that's not a surprise to any of you. And like any abstraction, there is a trade-off that you have to make, right? So there's, pros, right? You get all these cool features, you get to solve problems. Hopefully that's why you're doing this. And you maybe get to impress your friends with how cool you are with the latest cloud-native technology. But of course, you're going to pay for this abstraction, right? And the way we think about it, there's kind of three basic costs when you take a service mesh into your stack. There's a cost around resource consumption, right? So the mesh itself is going to consume memory and CPU, both on the control plane and on the data plane side. And then there's a kind of a distinct cost around latency. So the mesh is going to introduce latency, especially in the data plane, between your application components, and that latency might actually be user-facing. Right? So that's something you want to minimize as much as possible. And then there's a third cost around complexity, which is that there are human beings who have to wrangle this thing, at least until GPT-3 can do it for us. We're going to be involved in managing this mesh. And this is a talk fundamentally about that third bullet point, right? So talk about the complexity that's involved in mesh, and not complexity in the computer science sense of, like big O analysis or whatever, but complexity in the sense of, human beings having to spend their time and energy in operating the service mesh. And the reason why this is an interesting topic, I think, is because you can measure resource costs and latency costs in a way that's much more direct. Right? You can do that with benchmarking. And benchmarking, of course, is like a tricky thing to do. It's subtle, it's nuanced. The performance of a service mesh and the resource consumption of the service mesh is a very multivariable kind of dimension. But it is doable, right? There's organizations like Kinvoke and Meshery that have done these benchmarks. The projects themselves run benchmarks, and so it's a possible thing to accomplish, and an important one. But there's not really, in contrast to benchmarking, there's not really a easy direct measure of this kind of complexity. You can imagine like a social science experiment, maybe where we measure how many hours, like engineers spend under a variety of conditions. But in the absence of something like that, there's not a great way of measuring this directly. It's also, unfortunately, like kind of an important measure because ultimately, I don't think we really care. At least I don't care how hard the computers have to work. Right? Like they're computers, but I do care very much about how hard I have to work, and I care about how hard anyone who adopts a service mesh has to work. So it's important to measure this. It's really hard to measure. We can at least try and take a stab at it and talk about some examples of how the service mesh has been complex and things that we've done to try and address that. So I'm going to give a couple examples from the Linkerd side. Before I do that, we should talk a little bit about who is going to actually pay the cost, right? I'm talking about humans. It's actually three groups of humans, at least at a coarse approximation, who pay the cost. There's what we call the platform owners, right? This is the team that owns the service mesh. Maybe they also own Kubernetes, maybe they don't, but there's someone who's operating this thing, who's bringing it into their environment, and who is responsible for it. They pay this cost the most direct way. There's also kind of consumers of the service mesh. There's a developer community, who benefit presumably from the kind of the features of the service mesh, but maybe are not interacting with it directly or not configuring it directly. And then, of course, there's the business. So the developers pay the service mesh cost indirectly. The business presumably is literally paying for both platform owners and service owners, unless you're doing this for free, in which case, Godspeed. But the business is paying for all this to happen. And the more efficient we can make the service mesh and the less complex we can make it, then the lower the business costs as well. So three basic classes of humans. Okay, let me run through a couple of quick examples from Linkerd, and then I'll turn things over to Lynn after that. So on the Linkerd side, of course, there's lots and lots of examples of this, which maybe is a bad sign. I don't know. But Linkerd went through this very big transition from Linkerd 1.x to 2.0. In 1.x, we had this implementation based on the JVM, based on a library called Finagle. And in 2.x, we're now entirely off of that. We've got a new implementation, Go and control plane, Rust and the data plane, and so on. And we also changed our entire approach to config. So our approach in the 1.x branch of Linkerd was, hey, Finagle's this powerful library. Here's some YAML that controls every option. Go figure it out. And with 2.x, we said, okay, what we're going to do is we're going to see how far we can get you with zero config. Right, so one example is, of course, meshing a pod. Kind of the very first thing you have to do as a service mesh user. So in Linkerd 1.x, we use this node name environment or variable from Kubernetes. We pass that through to the HTTP proxy environment variable. We would then kind of expect your application to respect that environment variable and to wire all of its HTTP calls through Linkerd, and that worked maybe 80% of the time, and the rest of the time you as a developer would have to go in and change things. So it's a very complex kind of operation we expected of you just to use the service mesh. In 2.x, we instead allow you to annotate things at the namespace level, at the deployment level with a simple annotation, and the proxy injector and the init container or the CNI plugin kind of do all their magic to make this all happen for you. So a much simpler surface area. I think we actually stole/copied all that from Istio, right? Like, it's a lot easier that way. So thank you, Lynn, for that. Another good example is routing traffic, right? Linkerd 1.x, we had this very sophisticated language for doing kind of arbitrary traffic routing. You'd have to provide you with like this 300-line YAML file just for the act of like sending HTTP requests or gRPC requests or whatever. In Linkerd 2.x, of course, we have protocol detection. We understand a lot more about the Kubernetes environment, and you don't have to do any of that. In fact, you do nothing, and it just starts working. A third example, mutual TLS, right? 1.x, again, we gave you this big configuration file. We said, hey, if you put your certs in this particular location, then like we'll read them and we'll use them, but it's kind of up to you how to do this, right? Like you put them there and you manage them and so on. Like PKI infrastructure, how hard can it be? It's up to you, just figure it out. In 2.x, of course, we ship with a certificate authority, which distributes the proxies to distributes the certs to the proxies automatically and rotates them 24 hours. In fact, it's on by default. So the moment you add Linkerd to your system, you've already got mutual TLS. It's actually kind of hard to turn off. So big difference in kind of the level of complexity for getting this feature. And then the final one I want to go over, and this is kind of an interesting one, I think, from my perspective, is how do you inspect the state of the mesh? How do you understand what the mesh itself is doing? Right? In 1.x, again, we kind of left you up to your own devices. We said, hey, each proxy is exporting metrics. Do whatever you want with them, right? And in 2.x, we kind of took the opposite tack, which is, hey, it actually is a big deal for people to understand the state of their mesh, and we kind of have to own that problem. So we ship with a little Prometheus instance, a built-in dashboard, Grafana. We have a Linkerd check command. I'll show you output in kind of the next in the next slide. And importantly, the control plane runs on the data plane itself. So all the tools that we're giving you to understand the behavior of your application are the same things you can use to understand the state of Linkerd and the control plane components in the proxy. So here's some examples. On the left, we have the output of Linkerd check, which you can run like before you install Linkerd, after you install Linkerd, anytime you want. It's just going to do the sanity check of, is Linkerd working? Does it have the Kubernetes kind of features and permissions it needs, and so on. In the middle, we have the dashboard where we're looking at a view not only of like the control plane, green light, red light, things are good, things are not, but also just the generic view of what's a namespace doing that's been meshed, which you can apply to the control plane namespace just as well as you can apply it to your own application namespace. And then, of course, on the right, we've got all the Grafana graphs. It's the same thing that you're looking at. When you're looking at your application, you're going to see these same, through the lens of Linkerd, you see the same things. So for us, that was really important to get to the point where you as the operator could actually understand what was happening. Okay, so hopefully that's like a whirlwind tour of some lessons that we learned in Linkerd and how we try to address and minimize complexity for the user. At this point, I'm going to turn things over to Lynn. So, Lynn?
So I'm going to talk about some of the Istio examples. I tend to think Istio network resources are like puzzles. You not only need to understand what they are, but also the interaction among them. For instance, on this example, the service producer B here is importing external services, which may running also on VM. It needs to define what are the route rule and destination rule to reach out to that services, along with the configurations and the scope of the configuration as the producer. On the consumer side, the consumer service happened to be wired with Istio ingress gateway, so it would also need a bunch of configurations as well. The boundaries are actually getting clear now between the platform owner and the service owner starting in 1.6, as the platform owner can declare host, port, and TLS, and some of the other things like selector of the gateway and protocol for each of the team, A, B, C, D here as an example. The service owner would be able to be responsible for the virtual services and destination rule along with the configuration scope for that services. So it remains a clean separation among the platform owner and the service owner. I want to tell a story of I actually using the network resources myself with Istio recently. So what I did was I declared a simple TCP based routes so that when the user hits Istio D2, it would redirect the traffic to Istio D running on namespace Istio 2. Apparently, we've done a lot of configuration detection error through Istio analyzer, but it didn't detect what's wrong with my configuration in this example. And it took me a while. You may laugh at me, why would you actually associate host with TCP? But I did, unfortunately. So it took me a long time to figure out, hosts are not supported with TCP by talking to my fellow maintainers on the project. So this is when I upgrade my configuration to use TLS in this example, and I learned that the host on the gateway and virtual service are not really helping with the routing. I really need SNI host to do the routing. And then I discover Istio bug because these configurations are perfect, but I have to enable the sidecar proxy on my service. I have to enable the logs for that. I have to enable the logs for the Istio ingress gateway. And I still couldn't figure out what's wrong with my configuration. I reached out to other maintainers on the project. It turned out Istio and Envoy had a bug and not setting the host properly for the SNI host. And I filed a bug. So this is going to fix in 1.7 of Istio that's upcoming this month, that you can do SNI host routing for TLS protocol. Some of you know that I wrote a book last year called Istio Explained. It's really only have 3 simple services. And as part of the book, I added sidecar proxy to each of my services. And I also enabled mutual TLS for each of my services. The first thing I find out is my service have health check, and none of my services are working after I enable mutual TLS. The reason is the Kubernetes does health check, and it doesn't work very well when mutual TLS is enabled. Prior to Istio 1.6, user would have to put such annotation into their pod to enable Istio to do mutual TLS when the service have health check enabled, so the health check can be performed under mutual TLS enabled mode, which happens to be when the time my book was written. But since Istio 1.6, the annotation is actually enabled by default. So as a user, as you enable mutual TLS for your services, you no longer need to declare such annotation, which is nice. The second thing that stumped onto me was I find out the header-based route doesn't work for me. It turns out the services were communicating using secure communication before I even add the sidecar proxy. So for instance, the trade service would be talking to HTTPS to the sidecar proxy, and it doesn't enable me to do header-based routing with encrypted traffic. So I end up downloading each of the service to downgrade to HTTP, so the traffic will be plain traffic HTTP between the app container to the sidecar container. I also realized enable for me to do header-based routing, I actually have to make code change to make sure that header is propagated through some of my services that I want to enable for routing. So this is an interesting example that not only the platform provides different functions, but I really have to go into the application code to fully enable the mesh, the fully rich function of the service mesh. So that goes back to the fundamental question: how do we make service mesh boring so we don't have anything to talk about? Do you really need service mesh? One of the key scenario we went through as the Istio project is the control plane is no longer using microservices. We actually consolidate our control plane components back to monolithic. I find out Buoyant has an interesting checklist for users. Do you really need service mesh? And how many people are in your engineering organization, and how many microservices do you have? What if we can actually provide user an analyze function to help user analyze based on the state of the service mesh, whether they really need service mesh? For instance, I could run that command towards the 3 of my services in the trade namespace and find out all of the services are using Java. Maybe I shouldn't need service mesh and go through all the learnings. And maybe we can run it on a different namespace, and then you can find out it has more services, it has using different languages, and the mesh could be recommended. Zero configuration, William talked about zero configuration is possible, and same with Istio, with protocol detection, but really it comes with a cost. It's really great to do zero configuration for onboarding, but we do recommend the user to actually declare their protocol in production, so we don't have to kind of having that code to automatically detect the protocol for you. Zero code change, I learned the hard way, is actually not possible. There are different levels of your service mesh readiness for your code and your service. First, can you run your service with a sidecar? Are the headers for telemetry propagated? Are you doing any retry or timeout or maybe some secure communication in your code? Are these disabled so that you actually trust the service mesh platform to do it for you? What if you are using images from other people? Last Thanksgiving, I was put into a user issue that the user injected the sidecar proxy for Zookeeper, and they find out Zookeeper stops working completely. And this is even before they enable mutual TLS. So this is a clear example of the service doesn't even support running in the mesh with a sidecar. How is your application doing? William talked about some cool dashboard, right? If you know what application to look, it's easy. You can drill into there and find out exactly what's going on. This is an example of Kayali from Red Hat. But what if you want to know how your overall statistic of the mesh and be able to know which application to look into? For instance, do you have mutual TLS for all your traffic that you can actually tighten up the whole mesh for mutual TLS? What if some of your services, maybe in a particular region, have issues? So we do think it's super valuable to have overall dashboard so that you can actually drill into whichever has the problems. In conclusion, through these examples, we really hope and we will continue to work to make service mesh easier for you.
All right, we did it. Hey everyone, thanks for watching our talk. Here we are, we're live, we're ready to answer your questions.
Okay, William, I saw a question come.
Okay, I can't hear Lynn. Sorry, Lynn. Just as you started speaking. Well, maybe I'll try and add a little bit while Lynn tackles her audio. So we had a question from Dennis, which is, in what kind of applications do you think that it's worth the effort of using a service mesh? I think that's a great question. Lynn kind of touched on that in her portion of the talk. So hopefully that made sense for you. But in my mind, it kind of comes down to a couple factors. One is on the technical side. If you're running a monolith, it's not going to do a whole lot for you, unfortunately. If your application is split into lots of microservices, okay, then great, it starts making sense. If your application is polyglot microservices, so different languages, then it definitely starts making sense. And then if your team, the organization around it is large and there's lots of people and you kind of have this natural split into people who own the platform and people who own the application itself, then it really starts making sense. So those are the basic factors I would consider. I'll plug I wrote a service mesh manifesto at some point where I kind of talked about some of this. It's on servicemesh.io. So I'll plug my my manifesto because I have a lot more opinions. Lynn, are you back? Did the answer make sense to you?
Yes, I am back.
Great.
Yeah, the answer definitely makes sense. Yeah, I do think it's worth to evaluate whether you actually need the service mesh to go through the learning, because the learning is not a small amount of learning.
Yeah, agreed. Okay, wow, we got a lot of questions coming in. That's great.
So there's a related one, which Lynn, maybe I'll ask to you, and you try and answer it. So Anwar asks, with all the complexity with service meshes, at what point would it be helpful for developers or organizations to adopt the mesh? So I think it's a similar question, but is there a point at which maybe the application, grows or the organization grows and suddenly you switch into, oh, we do need a service mesh?
Yeah, so I think there are a couple of fronts. So first, you have to look at the size of your team and also the number of your services. Secondly, you have to look at what programming languages are you using, right? If it's the single programming language like Java, it may not be as attractive as a diverse set of languages. Interestingly, the Istio project gone through this for the past year or so, and we had like control plane distributed into like 4 or 5 components, but it was written in the same language, so the value wasn't obvious to us. I think the other thing you want to look at is the delivery timeline for each of your services. If all of your services are delivered in the same timeline, maybe the value is less. But if they are onto different schedule, you want to deliver them separately, it's controlled by separate team. So the people and organization perspective are super important as well.
Yeah, I think that makes a lot of sense. Okay, I see a question that I kind of want to answer from Girish, which is, what's the need for SMI when you are using the service mesh? I think that's an interesting one. So SMI is the service mesh interface. It's a API, and as I understand it, the goal of SMI is to provide an API that's kind of independent of the service mesh implementation under the hood. So there's a set of there's a set of APIs around metrics. There's a set that's around kind of traffic routing and so on. And the question is like, what's the need for SMI when you're using a service mesh? I think if if your goal is I want to run the service mesh, I don't think you have a direct need for SMI. But I think, as I understand it, the goal is, if you are building tooling that sits on top of the service mesh, then having an API that is uniform across mesh implementations is actually really helpful, because then you can build your tool against that API rather than building it against an individual mesh. The kind of classic example at this point is the Flagger project, which does this progressive rollout. So it'll do like a canary deploy and shift traffic and monitor success rates and so on, and it can unshift traffic if success rate is going down. Something like that is built on top of the SMI traffic split API, and that makes perfect sense, because now Flagger can run on, you can use Flagger if you're using Istio, you can use it if you're using Linkerd, you can use it if you're using something else. I think hopefully that answers your question, Girish. Again, I think it's less about you as the consumer of the service mesh directly using SMI. I think it's more about the tooling that it enables.
Yeah, I think, William, you are right on this question. I actually share a similar viewpoint as you. I would say, maybe when service mesh is really boring, when there's really not much variation between service mesh provider like Linkerd or Istio, maybe SMI could be interesting, because it would be more transparent for the user. But for today, because there are so many things to talk about and there are so many differences between different service mesh provider, the fact that SMI can only implement the common function among all the service meshes make it harder to actually adopt some of the new things and exciting things from service mesh today.
All right, we've got time for one quick answer then. And Lynn, I think this is a question for you. It's from Christopher. He says, is the idea for a mesh recommender something that you are actively working on?
It's actually something we discuss William and I kind of come up this, as we're working on this chats. So not something we're actively working on, but something definitely on our thought process. And we would certainly very value your feedback on whether if this is something tremendously important.
Yeah, great. Okay, so that's the end of the time we have for live Q&A, but both Lynn and I will be on the Service MeshCon. It's #3-Service MeshCon Slack channel, and we'll see you there.